Hi guys, I presume that this video would be very helpful in discriminating numericals in thermodynamics, in physics and in chemistry. Alright, so main contention was to take varieties of numericals belonging to chemistry and belonging to physics and correlate. Alright, so when in one platform you get to see numericals of these variations, it becomes very easy for you to understand the difference. Alright, so that was my main motto and I presume this would be helpful. Alright, so the earlier part which was there, that was theoretical discrimination between physics and chemistry, thermodynamics work type of situation, whereas this is discrimination in numericals of work in thermodynamics, in physics and chemistry. Alright, keep waiting. Alright. Okay, let's understand how is this numerical sorted. The work done during the expansion of 5 moles of an ideal gas at 27 degrees Celsius expands isothermally and reversibly from volume of 6 liter to 60 liter. Work done in kilojoule is. So these are the options. How do we sort it out? Now we know here what they want is isothermally and reversibly. So first of all what we would do is we would jot out the formula for work done isothermally and reversibly. Okay. So W max work done is equal to minus 2.303 nRT log final volume upon initial volume. Alright, why not just substitute the values that has been provided. Now we know this remains as it is. Now number of moles is 5, so we put in 5 into 5 into R. It's the gas constant. Now here we would be using, before we get into filling value for gas constant R, there are few things that you need to understand. Now we know gas law, which is PV is equal to nRT. So if we want to get in terms of R, it becomes R is equal to PV over NT. P is for pressure, atmosphere. V is for volume, so that is liter, and divided by mole, and temperature in Kelvin. So it becomes atmosphere liter per mole Kelvin. Alright, okay. Now we also know that pressure volume is a type of work, and work, unit of work is joule. So R can also be, unit of R can also be joule per mole Kelvin. Now we also know joule can be converted. 1 cal corresponds to 4.184 joules. So it can anyways be converted to calories also. So R can also take unit in terms of calorie. So it would be cal per mole Kelvin. Now the other units. Now values you have got to by heart. Now whenever we talk in terms of atmosphere liter per mole Kelvin, the value is 0.0821 liter atmosphere per Kelvin per mole. Alright, now whenever we are talking in terms of joules, it is 8.314 joules per Kelvin per mole. Alright, and when we are talking in terms of calorie, it comes to approximately 2 cal per Kelvin per mole. The confusion is, out of these three, which are to be applied when? It all depends upon the numerical. Now suppose if we are talking in terms of MCQs, then you have got to check out in MCQ what are the units that they have applied. So that becomes very easy. From that we have got to convert everything in terms of the unit that we decide. And then also you have got to check out in data. In case of normal numericals, in data you have got to check out all the parameters have been taken in which system. Alright. So in case of liters, you have got to use this. If it is in terms of calories, then you have got to use this. In terms of work, then you have got to use. So understanding the data from numerical, you are supposed to apply the value of R. Okay, let's proceed now. 8.314, and then it is provided as 27 degrees Celsius. So we add 273 to it, so it becomes 300. Alright, and log of 60/6. Now keep one thing in mind, that this can be cancelled. Alright, so it could become 10, and we know log 10 is 1. So if we multiply, what we get is minus 2.303 into, if we just multiply these values, what we end up with is 12471, and into 1, log 10 is 1. Alright, so we end up with minus 28720. This is joules, but all the answers given is in kilojoules. So obviously we have got to divide it by 1000. So that gets to minus 28.72 kilojoules. Alright, so the answer is B. Alright, now the main contention was just, this is a very simple sum, I do accept, but main contention was just to make you aware what formula to use when. Now when we are talking of isothermally and reversibly, this is the formula that we have got to use. Now let us check out other numerical. Okay, let's understand how do we sort out this numerical. Gas absorb 250 joules of heat and expand from 9 liter to 10 liter at constant temperature against external pressure of 5 atmosphere. Value of Q, W and del U will be respectively these. Okay, now on reading this sum, one thing is very clear, that it is pressure volume type of work, and again it is expansion. Alright, second thing is, we also have got to involve Q, W and del U. That itself means that we are dealing with first law of thermodynamics, where del U is equal to Q plus W. So without wasting time, let's get involved into it. Okay. So pressure volume type of work, jot it down. W is equal to minus P del V for expansion. Okay. Now pressure mentioned is 5. Change in volume is 10, 9. Final volume was 10. Initial volume was 9 into 10 raised to 5. Why 10 raised to 5? So we know the relationship. So we have got to convert this liter also into decimeter cube. Now we know 1 liter corresponds to 1 decimeter cube, and 10 cube decimeter cube corresponds to 1 meter cube. So 1 decimeter cube corresponds to 10 raised to minus 3 meter cube. Alright. So along with this 10 raised to 5, we also have got to put here 10 raised to minus 3. So this 10 raised to 5 belongs to conversion of this 5 atmosphere to Pascal, and this 10 raised to minus 3 is for converting this liter, or rather decimeter cube, to meter cube. Alright, so now on further solution, what we end up is with this becomes 1, this again becomes 2, 10 raised to 2, so we can jolly well put it as 500. Now confidently we can put in joules. Okay, now so confidently, but now our job is not yet done, because we are also interested in to getting Q, W and del U. So it is work is minus 500. All right, okay, so now let's get into del U. We are now into using first law of thermodynamics, which says del U, internal energy is equal to Q plus W, where Q is heat absorbed. Now they have already mentioned that heat absorbed is 250 joules, so I would jot down 250 joules, and work that we found out was minus 500 joules. Alright, so this entire thing was joules, so ultimately we end up with minus 250 joules. Okay, so can we check this out? So it is 250 minus 500 and minus 250. Alright, so here we have got to talk in terms of Q. Q is 250, W is minus 500, and del U is minus 250. So see, again the answer is B. Okay, now comes physics. A gas enclosed in a cylinder is expanded to double its initial volume. Vi is equal to 0.5 units at a constant pressure of 1 atmosphere. How much work is done in its process? These are the options. Obviously expanded and volume given at constant pressure, 1 atmosphere given. So this definitely is pressure volume type of work. But keep in mind, this numerical has been asked in physics. So what changes come? Let's check it out. That's the main purpose of taking this numerical. What we do is, first we jot down the formula, pressure volume type of work, but we know since it is physics, so it is positive P del V. That's the change that we see here. Alright, okay, so this is equal to P V final minus V initial. Now what they have mentioned is gas enclosed in a cylinder is expanded to double its initial volume. Alright, to double its initial volume. If I say that Vi is initial volume, then Vf would be 2Vi. What is? So it would be Vi, they have mentioned is 0.5 unit. So it would be P into Vi. So it would be pressure. It would be pressure into 0.5. Alright. Now 0.5 units they have mentioned. Now again pressure over here is in atmosphere, but we want answer in joule. So we have got to convert atmosphere to Pascal. Alright, for doing so we have to multiply that into with 1 atmosphere, right? So I can put in here 1 into 0.5, but I've got to convert that 1 atmosphere into Pascal. So it would be 0.5 into 1.01 into 10 raised to 5. That would come to 5.05 into 10 raised to 4 joules. Alright, so this was conversion factors. Alright, so we here when we were here at that time, this was atmosphere. Now when we are here, this got converted into Pascal. Alright, so the answer that we got was 505 into 10 raised to 4 joules. Oh, for a change, the answer is A. Alright, so we saw the major change that we saw was sign in case of physics. Alright, though we expanded, but the work was positive. Okay guys, this is a question from textbook itself. This would help my purpose, obviously from physics. A gas contained in a cylinder fitted with a frictionless piston expands, its expansion again, against a constant external pressure of 1 atmosphere from a volume of 5 liter to volume of 10 liter. In doing so, it absorbs 400 joules of thermal energy from its surroundings. Determine the change in internal energy of system. Okay, now already we know that it is pressure volume type of work. It is expansion. So the formula that we have got to use is P del V. Work is equal to P del V. Alright. Obviously, del V is Vf minus Vi. Now, since it is of physics, so it is positive P del V. Why? Because it is internal pressure, not the external pressure. Alright. Okay. So, now what we do is we just substitute the values. Now, pressure, what has been given is atmosphere. But we want answer in joules. So, we have got to convert it into joules. So, obviously, we have got to multiply it with 1 atmosphere. We have got to multiply it with 1.013 into 10 raised to 5, which is the conversion factor of atmosphere to Pascal. Alright, so done. So this is converted into Pascal. So now we are all towards joules. Alright, so now change in volume. Volume has been provided in liter. So we already have, in my earlier video I had shown that liter is decimeter cube. 1 decimeter cube, 1 liter is 1 decimeter cube, and which also is equal to 10 raised to minus 3 meter cube. Alright, so what I do is I put in change in volume, that is 10 minus 5 into the conversion factor into 10 raised to minus 3. Alright, so now we just calculate it. So this is what is work. So on calculation, the value that we end up with is 5.065 into 10 raised to 2 minus 3 plus 5, law of indices, 2, and just simple multiplication. Here what we end up is with 5. So, and this is 1013. So 3 5s are 15, 5 1s are 5, 1 carry added to that. So 6 5 zeros are 0, 5 1s are 5. So we end up with this value. Now obviously the unit of this value would be joules. Now if I intend to take in this value, so it would be 506.5 joules. Alright, one part of job is done. So work is found out. It is positive because we are in physics. Okay, it would have been expansion in physics, so it is positive. Now the next part is, now what we have got to apply is first law of thermodynamics, which says del U is equal to Q minus W. Now the magnitude of Q minus magnitude of W, that is what is internal change in internal energy. So del U would be Q absorbed In doing so, it absorbs 400 joules. Alright, so 400 joules is the amount of energy that has been absorbed minus work. That's what we found out. It is 506.5 joules. So we end up with minus 106.5 joules. Alright, so this is what is our solution. Hope this video helped. Keep viewing. See you soon.